Good day, everyone. This is author St. Vincent, the author of Mathematics, Accounting, and Finance. I'm here to take mathematics for senior secondary and the equivalent. Today, I'm going into my textbook, Teach Yourself Mathematics. Teach Yourself Mathematics. I'm moving to chapter 4 of my textbook, which is on the topic called number bases. And on page 30, I have taken some of these questions and I'm going to do justice to them so that I will throw more light on this topic so that when you have the pleasure of having a copy of the book, you can read more and ask questions where the need arises. Without wasting much of our time, you're welcome. The first question, this is number bases. How to write in different bases. As far as number base is concerned, we convert from any base to base 10. Base 10 is the common or basic base. You either move from 10 to other bases, or you move from other bases to base 10. That means we can move from base 12 to base 10. We can move from base 10 to base 13, base 15, base 16, and so on. So, but this first one is conversion. Converting from any base, this is base 2, converting to base 10. Another name for base 10 is denary. Another name again for base 10 is converting to decimal. Even the currency we'll talk about all over the world is in base 10. So we move from any other base to base 10, or from base 10 to any other base. If we are moving from any base to base 10, we'll talk about multiplication, addition, multiplication, addition, and raising the thing to power. Without wasting much of our time, solution to this particular problem. The first one, you will agree with me that the first question will go this way. Solution. 101.011 in base 2. Converting all this from base 2 to 10. The first 3 digits, 101, is a whole number. And the last 3 digits are decimal. So this is how we start. We say the first digit times the base we are on plus the second digit times the base we're operating plus 1 times the base we're operating. If you look at what I have done, 101 is a whole number. With that 101, if you look at what I did here, these are 3 digits, 101. When I take the first digit, I'm left with 2 digits, that's raised to power 2. When I take the second one, I'm remaining with 1 digit, that's raised to power 1. When I took the last one, no more digits is left as far as whole number is concerned. That will be raised to power 0. If you so, we just take your time. The whole number, 1 times 2 plus 0 times 2 plus 1 times 2. The last multiplication, the base, raise the base to power 0, raise this to power 1, raise it to power 2. After that, the next number after the point will go this way, plus 0 times 2. If you look at the arrangement, it's in the same order, 2, 1, 0. After 0, the next thing should be minus 1, plus 1 times 2 raised to power minus 2, plus 1 times 2 raised to power minus 3. That's how it will be. You discover that the way I handle it, you will discover that the problem is raised to power 1, raised to power 2, raised to power 3. And with this, you can sort out the problem. Without wasting much of our time, we have 2 raised to power 2 is 4. 4 times 1 is 4. Plus 0 times any number is 0. Plus 2 raised to power 0 is 1. 1 times 1 is 1. Plus 0 times anything here is 0. Plus 2 raised to power minus 2. Law of indices will make it 1 over 4 plus 2 raised to power minus 3. Law of indices 1 over 2 raised to power 3, which is what? 8. Without wasting much of our time, this is 4 plus 1, that is 5, plus 1 over 4 is 0.25. Your calculator can do that. Plus 0.125. From all indication, we add everything together. We'll have 0.25, that will be 375. So answer will be 5.375, all in base 10. That is how to handle question number 1. Converting from any base to base 10. The principle remains the same. Even if that my base 2 was in base 5 and I'm asked to convert to base 10, those 2 will just change to 5 and not the rest of it. If it is from base 8 to 10, the process remains the same. As far as you are asked to convert to base 10 from any base, the process remains the way I have done it on the board. Moving on to question number 2. Question 2, which is 1, 2, 3 in base x equal to 2, 7. 2, 7, whether I write 10 or not, is already in base 10. Whether there is ten or there is nothing, it means it's in base 10. But assuming this 2, 7 was in another base like 9, all I will do is to convert both sides to base 10. But in this case, if you convert 27 in base 10 to base 10, it's still 27. So you don't need to bother converting that. The same process, 1 times x plus 2 times x plus 3 times x raised to power 0, raised to power 1, raised to power 2, all equal to 27. Here is x squared plus 2x plus 3 equal to 27. What that one simply means is that here x squared is x squared. X squared times 1 is x squared. 2 times x is 2x. 3 times 1 is 3. So we have here x squared plus 2x plus 3 minus 27 all equal to 0. X squared plus 2x minus 24 all equal to 0. This is now quadratic equation. And when conversion has led to quadratic equation, you need to apply the formula or the methods required in solving quadratic equation. We can solve using factorization method. We can solve using quadratic formula. There's nothing like almighty formula. Mathematics says it's quadratic formula. It's not almighty. It's only God that remains almighty. So we solve using factorization method, quadratic formula, completing the square, and graphical method. But now I'm going to use a factorization approach. And that factorization approach, I'm going to factorize. If you look at the board, you will see minus 24. Minus 24 is the constant there. That minus 24 does not have x attached to it. So it's a constant. Allow that constant to multiply everything about x squared. It will give us minus 24x squared. So that minus 24x squared, you will think of, for instance, this is minus 24x squared, which we'll call the product. This product, you will think of two factors that you multiply together to give you 24. And these two factors, when you add them or find their difference, it will give you the number at the middle, which is 2. So I can think of 6 times 4 as 24. And 6 minus 4 as what? 2. Then x squared is x and what? X. And then factors of minus is minus, plus, or plus, minus. So I need more of plus at the middle. So this bigger one will take a plus. This smaller one will take what? A minus. So these two factors, when you multiply them together, we'll get this. When you add these two together, you have the one at the middle. Then I can start factorization. Without wasting much for a very good time, we'll go this way and quickly run x squared plus, instead of these two x, we'll replace it with the factors, which is 4x minus 24 all equal to 0. We take them in twos. The first two, what is common is x. X plus 6 minus 4 into x plus 6 all equal to 0. If you have done a good job, x plus 6 and that one, x plus 6 must be the same. So that x plus 6 is a common factor. Bring it out. Use it to divide itself. You are left with x. Divide itself. You are left with minus 4. All equal to 0. X plus 6 equal to 0. Or in a simple language, x plus 6 equal to 0. Or x minus 4 equal to 0. Therefore, x is minus 6. Or what? 4. But remember, we are not solving quadratic equation from the beginning. Our number base led to quadratic equation. And base can never be negative. Base will always be positive whole number. That is what our number base is all about. So these two values, I have a minus, I have a plus. Therefore, I will now choose x equal to 4. So that means that x is in base 4. Without wasting much of our very good time, I haven't seen how to convert, how to convert from any base to base 10, and how to see conversions that lead to quadratic equation from that number 2. Number 3, we are going to finally see how to add in different bases. If you look at the board, here is 2, 2, 2, 2, and I'm adding in base 4. Because I'm carrying my addition in base 4, none of my answers will be up to 4. If there's anyone up to 4, I must divide by 4 and always write down remainder. For instance, 2 plus 2 is 4. 4 plus 3 is 7. I can't write 7. I will say, how many 4 can I find in 7? One time. Remainder 3. Always write down the remainder. Remember, this is 2 plus 2, which is 4, plus this is 7. 4 and 7 is 1. Remainder 3. I'm carrying the 1 to the next level. 3, 6, and then 9. 4 in 9 will be twice. Remainder 1. Carry 2. Here will be 4, 5, 8. So 4 in 8 is 2. Remainder 0. I write down the 2, 0, and then carry 2. I'm writing this 2 because the 2 is not up to 4. And that becomes the final answer to that particular question. If you look at it, take your time and look at it very well, you will agree with me that that is the solution to the problems on that board. This is mathematics for senior secondary. Those preparing for this kind of exam should take note. On that note, if you have a question, please put it in the comment section, or you can call me on 080-333-51748 for online coaching, for any extra or questions. You want to get copies of my textbook, Teach Yourself Mathematics. God bless you. See you next time.